On the surface, water plays by a simple rule. At 212 degrees Fahrenheit, or 100 Celsius, it boils. It's one of the first things we learn in science class. But what if I told you that deep beneath the waves, in a world of total blackness and crushing pressure, there's water being heated to over 750 degrees Fahrenheit, hot enough to melt lead, and yet, it never ever boils? This isn't sci-fi, this is planet Earth. And to understand how this is possible, we have to take a journey 2.5 kilometers down, into one of the most extreme and alien environments you can imagine. The longest mountain range on Earth, hidden completely under the sea. Our journey begins not with a splash, but with a slow, quiet fall. We leave the sunlit world behind, and as we sink, the pressure builds relentlessly. The light fades fast, first to a deep blue, then a permanent twilight, and finally, a perfect blackness that has never seen a single ray of sun. The temperature drops to near freezing. Down here, the weight of the ocean is staggering, a force so intense it would crush a person in an instant. We're intruders in a realm where the pressure is so high, it actually starts to change the rules of nature. Our destination is the mid-ocean ridge, a colossal planet-spanning volcanic chain where Earth's tectonic plates are pulling apart. This is where New Planet is literally being born from magma rising from the mantle. It's a violent, unstable place, and it's here, in the cracks of this volcanic seam, that we find our impossible volcanoes. For decades, scientists figured these ridges were just barren, lifeless deserts, a place too dark, too cold, and under too much pressure to support anything. They couldn't have been more wrong. It's 1977. A team of geologists is exploring a ridge near the Galapagos Islands, and they send down an unmanned probe. They're expecting to see some cooling volcanic rock. Instead, their cameras capture something that would rewrite our understanding of life forever. Imagine you're floating in that absolute cold and darkness, and your vehicle's lights cut through the void. Then you see it. Looming out of the black are these bizarre towering chimneys, some as tall as buildings. And billowing from the top is a thick black cloud, like smoke from an industrial smokestack. They were nicknamed black smokers. But it wasn't smoke at all, it was water, superheated, mineral-rich water, blasting out of the seafloor. The sight was stunning, but it was the temperature readings that broke all the rules. The water erupting from these vents was over 750 degrees Fahrenheit, or 400 degrees Celsius. And that raised the big paradoxical question. In a world of near-freezing water, how can you have a geyser hot enough to melt metal that simply refuses to boil? The answer is the one thing this environment has plenty of: pressure. At the surface, when you heat water, the molecules get energized, move faster, and eventually break free as steam. That's boiling. But go 2.5 kilometers deep, and you have the weight of all that water pressing down. The pressure is hundreds of times greater than at sea level. Think of it like a giant planetary pressure cooker. The immense weight of the ocean overhead physically prevents the superheated water molecules from expanding and turning into gas. The boiling point at that depth is just way, way higher than 750 degrees. But that's only half the story. Where does all that heat come from, and what's making the black smoke? It turns out, it's a masterpiece of geological plumbing. Cold, dense seawater, just a few degrees above freezing, seeps down through massive cracks in the ocean floor. As it sinks deeper, it gets closer and closer to the magma chambers bubbling just beneath the thin crust. Heated by the planet's molten heart, the water becomes a supercritical fluid, a weird state of matter that's not quite a liquid and not quite a gas. In this energized state, it gets aggressive. As this superheated fluid races back toward the seafloor, it strips minerals right out of the volcanic rock: hydrogen sulfide, iron, copper, and zinc. Then, finally, this superheated chemical-rich water erupts back into the ocean. That black smoke, you see? It's a chemical reaction happening in real time. The second that 750-degree fluid hits the near-freezing seawater, the dissolved minerals instantly solidify. It's the iron and sulfur compounds that form the dark particles, creating those billowing black clouds and building the chimneys themselves. particle by particle, over thousands of years. So you have an environment with crushing pressure, total darkness, and toxic chemicals erupting at temperatures that can melt lead. It should be the most lifeless place on Earth. But the truly incredible thing is, it's not. If you're fascinated by the hidden wonders of our planet, make sure you subscribe, because the story of what lives here is just getting started. The discovery of hydrothermal vents didn't just solve a geology puzzle, it completely shattered our understanding of life. We had always believed that all life on Earth ultimately depended on the sun. Photosynthesis was the foundation for everything. But here, in permanent darkness, scientists found bustling ecosystems. Oases of life were crowded around these vents, completely cut off from the world above. Ghostly white crabs scuttled over the rocks, strange snails piled on top of each other, and most bizarre of all, forests of giant tube worms, some over 6 feet long, with blood-red plumes swaying in the current. None of this should be possible. So how do they survive? They use a process that's to the deep sea what photosynthesis is to the surface, chemosynthesis. Instead of sunlight, the life here runs on pure chemical energy. At the bottom of this food chain are amazing bacteria that eat the toxic hydrogen sulfide, the stuff that smells like rotten eggs, that pours from the vents. Through chemosynthesis, they convert this poison into energy and organic matter. These bacteria are the foundation for everything, but the giant tube worms have taken it to another level. They have no mouth and no gut. Instead, their bodies are packed with these symbiotic bacteria. The worm's red plume acts like a lung, absorbing hydrogen sulfide from the vent and oxygen from the seawater, and delivers them to the bacteria living inside. In return, the bacteria produce all the food the worm needs. It's a perfect partnership, an entire ecosystem powered not by the sun, but by the chemical energy of the Earth itself. For decades, we thought these oases of life were just clinging to the visible chimneys on the seafloor. But a recent discovery proved this was only the tip of the iceberg. Scientists used a robotic sub to do something clever. They started overturning chunks of the volcanic crust, the vents, and what they found was astonishing. A whole new world. A network of underground caves and cavities, filled with moving water, hidden just beneath the ocean floor. And incredibly, these caves were teeming with the same kinds of life. Worms, snails, and bacteria, all thriving in a hidden habitat. The water flowing through these underground tunnels was a much more comfortable 75 degrees Fahrenheit. They realized animals were using this subterranean plumbing to travel, releasing their larvae into the vent fluid to be carried under the seafloor to colonize new vents. The habitat wasn't just a few spots on the map, it was a multi-layered world, with life existing both on and under the planet's crust. But what happens when the geological plumbing shifts and a vent goes out? The chimney goes cold, the chemicals stop flowing, and the vibrant communities die off. These are known as inactive vents. For a long time, everyone assumed they were just dead zones. But even here, life finds a way. Researchers now know that even these cold, dead vents host their own unique communities of tiny animals, supported by microbes that have learned to do something even more remarkable. They aren't consuming chemicals from the water anymore. They appear to be consuming the solid minerals in the rock itself for fuel. This incredible resilience has led many scientists to a profound idea. What if an environment like this wasn't just home to strange life? What if it was the very cradle of all life on Earth? The origin of life is one of science's greatest mysteries. But these vents provide all the ingredients in one place: a constant source of chemical energy, a rich supply of minerals, and countless tiny pores in the rock that could have acted as natural test tubes, kickstarting the reactions that led to the first cells. It's a powerful theory that the first spark of life wasn't ignited in a warm little pond on the surface, but forged in the dark, high-pressure, chemical-rich heart of an underwater volcano. We started with a simple question: how can you have 750-degree water that doesn't boil? The answer was pressure, the crushing weight of the deep ocean. But the real discovery wasn't about physics. It was about life. Hydrothermal vents proved that life didn't need the sun. Entire ecosystems could be powered by the raw chemical energy of our planet. Since they were first discovered, nearly 600 new species have been found in these habitats, each one a testament to life's sheer tenacity. And here's the most mind-bending part. Scientists estimate that if you took all the hydrothermal vent fields on the entire planet and put them together, they would occupy an area of only about 50 square kilometers, a space smaller than a medium-sized city. They're a powerful reminder that our planet holds secrets in its deepest corners that are as alien and wondrous as anything we might find in outer space. We've explored more of the surface of Mars than our own ocean floor, and down there, in the darkness, the planet is still building itself, and its impossible volcanoes are waiting,